Hey everyone, welcome back to your math class. And today you can see I am in a little bit of a different space. I'm recording this on my lunch break, so hopefully that's fine and there's no issues with the audio and stuff. But yeah, so today we're just going to go through a little bit more practice working with one variable, since that was giving you guys some trouble last week. And of course, a slightly belated Happy Independence Day to all of you for this past Tuesday when you guys didn't have class. But yeah, let's dive right in. All right, so the plan for this video is we're going to briefly review how to solve problems involving one variable, so like one unknown quantity that's showing up throughout your equation. Now that doesn't mean that it's only going to show up once. You could have the same unknown value, so like represented by the letter x, let's say, but you could have it show up a few different times in the equation. That's still one variable because it's only one number that you don't know the value of, and you just need to figure out what that is. So we're going to briefly review how to do that. Following that, we will do a few practice questions. And after that, you guys can go back to lesson 10 and finish the word problems from last class. So let's dive right into the brief review, and then we'll do the practice questions. So first things first, just a quick review on how to solve problems involving one variable. So I've taken this screenshot right out of lesson 9, I believe. So this is the slide that was talking about the key takeaways from problems involving one variable. So the idea is the main goal of most of the problem is isolating the variable. So what that means is you have to get one number, or well, you have to get the unknown number, so like the x, let's say, by itself on one side of the equal sign, and then all the other stuff, all the other numbers are on the other side of the equal sign. So of course, the way we've been solving the problems, as soon as we move numbers over to the other side, we kind of deal with that with the math over there as quickly as possible. So you won't normally see like x equals and then a whole bunch of stuff. It'll usually be x equals and then it'll be something like a fraction or a simple addition or division problem, something like that. And there's not much else to it. And to remind ourselves how we isolate variables, we follow the BEDMAS steps in reverse. So that's something that we talked about in the last class or two. And if you guys need a refresher of that, you can go back and watch that video. That's the power of YouTube. But of course, if there's something that's still missing from that explanation, let me know and I can do that again. But yeah, so basically we want to perform the BEDMAS steps in reverse. So basically we start out, when we're trying to isolate the variable, we start out looking for addition and subtraction because it's the easiest to deal with. Then we move to multiplication and division. Then we move to exponents, which we haven't really talked about yet. And then we move on to brackets as the last step. And we always do the opposite operation, because if you've got like x plus 5 on one side of the equal sign, you want to undo the fact that you've done x plus 5. So to undo plus 5, you have to do minus 5. And if you do minus 5 on this side of the equal sign, then you have to go over here and subtract 5 on that side as well. So yeah, so this is just from that slide from a couple of lessons ago. So if you've got x and it's tethered to a couple of other numbers through multiplication and subtraction, let's say, then you first perform addition, because we're doing BEDMAS in reverse, and then division to undo that multiplication and the subtraction that are keeping the x tied up with all these other numbers. So now we're going to dive into some other practice problems, similar in style to the ones that you saw last lesson, but just for a little bit more practice. So you guys can take a few minutes, pause here and try and solve these problems. You'll see a couple of them have the x show up multiple times and then a couple of them don't. So take a few minutes and work through that, and on the next slide we'll look at the answers. All right, so here are the answers to the 4 practice questions. So hopefully I didn't make any mistakes, but we can quickly check those right now. So hopefully you guys got answers that look like this. If you chose to write something out as a decimal, or you forgot to like reduce a fraction or something, that's okay for now. We're trying to just figure out if we can get the right value for x, and we're not too bothered about how we write it at this point. So the quick check that you can always do if your answer is right is take the answer that you've found and then plug it back into the original equation that I gave you and see if you get that the left side and the right side of the equal sign end up actually saying that they're equal to the same number. So in this first case, I said that x is equal to 5 1/3. So if we plug that back in over here, then that's going to be 3 times, so this x becomes 5 and, oh, that's really bad writing, but 5 1/3 is what we're plugging in place of this x. So 3 times 5 1/3 is going to come out to 16. So if we do 3 times 5 1/3, right, because we're replacing the x by this. So if you turn that into an improper fraction, this thing will turn into 16/3. And then of course, if you multiply that by 3, then you cancel it out with this 3 in the denominator and you're left with a 16 minus 4, which is indeed 12. So this first one checks out. The second one, I've said x is equal to 11. So if you plug in 11, you get 13 on the left side, and 24 minus 11, that's 13 on the right side. For this third one, what we've got here is the x is sitting in the denominator of the fraction, so this is a little bit tricky. So what you need to do is you need to multiply both sides by x so that you don't have to deal with x being in the denominator. This one's a little bit tricky. So if you multiply both sides by x, so if I write in an x over here as multiplication, that's supposed to be like that, and then I write in an x over here, then those two x's on the left side will cancel each other out. So this and this disappear. You're left with 21 is equal to 24 times x. And then after that, you can divide by 24 on both sides. So then we end up with a 24 down here. And so, of course, on the right side, this 24 and that 24 disappear, and you're left with x is equal to 21/24, which you can then reduce. If you divide the numerator and the denominator by 3, then you get 7 in the numerator and 8 in the denominator, which is how I got this answer of x equals 7/8. And then this last one, I said x is equal to 25. We can plug x in to check. So if we plug in x to check, then we get 3 times 25, that's 75 minus 12. 75 minus 12 is going to be 63. And then on this side, we've got 2 times 25, which is 50, plus 13, which is 63. So that's how you can check your answers. Now, I hope you guys did get the same answers that I got. Now that you've had, I think, a little bit more time to explore how we got the answers that we did. But yeah, of course, let me know if you guys are having any trouble with that. So you can pause here if you'd like. If you guys had a little bit of trouble, pause here, discuss how you got the answers that you got, and we'll see if we can clear up the confusion kind of collectively. So assuming that that's done, what you can do now is so before we dive into going into more practice questions or word problems or anything, I do want to tell you one thing, which is that, so the way we've been isolating variables and like kind of changing stuff in the equations is we've been adding or subtracting or multiplying or dividing by the same number on both sides of the equal sign to undo something. So if you've got x plus 5 on one side of the equal sign, then what we've been doing is we've been doing minus 5 over here and minus 5 over here so that we get rid of the plus 5 on the left side, and then those disappear on this side and you end up with something else on the other side. That's totally a fine way to do it. If that's been working for you guys, then great. The other way that you can do it, it's a little bit of a shortcut basically, but you're achieving the same goal, is you can move a number that you want to get rid of. So if you've got x plus 5 on this side of the equal sign and you want to get rid of that plus 5, you take that 5 which is right now being added to the x. So it's like a positive number, x plus 5, right? Positive 5. So if you take that 5 and you just move it over to the other side of the equal sign, flip the sign. So if it was a positive number, make it a negative number. If there was addition before, make it subtraction now. And that's it. That's kind of a shortcut. So instead of having to do like minus 5 over here and minus 5 over here, you just take the 5 from this side, you move it over there, and you flip the sign. So if it was a positive 5, if it was like x plus 5, now it'll be minus 5 when you take it to the other side of the equal sign. If you had something that was being multiplied on this side, you take it over to the other side of the equal sign, now it becomes a division, so you're dividing by that number. If you had a positive number, like it wasn't something plus 5, but it was just a 5, and you move it over to this side, then it's going to become minus 5, so things like that. Yeah, so I just wanted to tell you guys that it's a little bit of a shortcut. We're going to do one example that gives you a little bit of practice isolating the variables, but it's also going to be something that just highlights these two methods. So the first way is the way we've been doing so far in class, and then I'm going to redo the exact same example the second way, just so you can see the kind of difference in thinking. So I haven't asked you guys to solve this example on your own, because I mean that's why I've called it an example, is it's something I want to kind of walk through the steps with you before I send you on your way to do some more practice on your own. So this is the question that we've got to deal with. 8x minus 5 is equal to 6x plus 1. That's the equation that we have to deal with. We have to figure out what x is equal to. So if we wanted to solve this the way we always have been, the way I would start is we want to isolate the x. So we want to get every term, every little clump of stuff. This little 8x, that's one term. This minus 5, that's one term. 6x, that's one term. And this 1 at the end, that's also one term. So I want to get all the clumps of stuff, all those terms that have an x in them. I want to get those on one side of the equal sign, and I want to get all the numbers on the other side of the equal sign. So my first step is I want to bring the 6x over to be with the 8x. So in order to do that, I need to get rid of the 6x from this side. So I subtract 6x from the right side, which means I also have to subtract 6x from the left side, which means that if you go through that math, you're going to get 8x minus 6x, that's 2x minus 5. So that's where this 2x minus 5 comes from. And then on the right side, the 6x and the minus 6x just disappear, so we're left with just the 1. That's all the stuff in black. Then basically what we have is 2x minus 5 equals 1. And we want to get rid of this minus 5 because we've already got the x's all clumped together, but now we've got this pesky number sitting next to it. So we get rid of this minus 5 by adding 5 to this side. But of course, if we add 5 to this side, we have to add 5 to that side. So on the left side, we get 2x minus 5 plus 5. And that minus 5 plus 5 is just, that's 0. So it's going to be just 2x. So that's this 2x down here. And on the right side, we've got 1 plus 5 is 6. So that's this 6 right here. So we've got 2x is equal to 6. And then in the red, we're dividing by 2 to get rid of that multiplication between the 2 and the x over there. So we divide by 2 on the left side. We divide by 2 on the right side, and we're left with x equals 3. So that would be the answer to this question, and then you can check that you've done it right by plugging the 3 in right here and right here. So if we plug in a 3 right here, 8 times 3 is 24. 24 minus 5 is 19. And on the right side, 6 times 3 is 18, plus 1 is 19. So we've got 19 equals 19, so that's the right answer. And now this is the exact same problem, but what I've done now is I'm just solving it the other way, which is instead of, so we had this 8x minus 5 equals 6x plus 1, and instead of subtracting 6x from both sides or adding 5 to both sides, I'm going to take this 6x in blue, which right now is a positive 6x, right? There's no minus sign in front of it, so it's a positive 6. And I'm going to just move it to the left side of the equal sign. So positive numbers become negative. So I'm taking this positive 6x and I'm shoving it over onto the left side, so it's going to become a negative 6x, which makes this a subtraction problem. And this minus 5 in red in the first line, I'm going to take that minus 5, or like that negative 5 really, and I'm going to move it over to the other side of the equal sign, and I'm going to change the sign. So the minus sign becomes a plus sign. So that way in one step I've kind of moved all the things around. So I've got all the stuff with x's right here all together, and then all the stuff without x's over here all together. And so then you can do a little bit of math to simplify that. 1 plus 5 is 6. 8x minus 6x is going to be 2x. So we've got 2x equals 6. And then here you could divide by 2 on the left, divide by 2 on the right. The way I tend to think about it is I'm going to take this 2 that right now is being multiplied to the x. I'm going to throw it over onto the right side. And I'm going to turn that multiplication into division. So this 2x, I'm just taking the 2 and I'm lifting it out of the left side, so we've got just an x left over. You bring it over to the right side, but instead of multiplying, now you're going to divide. So it becomes 6 divided by 2, which is 3. So that's, I wanted to give just a very quick example explaining this way of kind of thinking about it. If this confuses you, don't worry about it. Do it the other way, the way that we've been doing it so far. If this is something that you'd kind of seen before and you just need a little bit of a refresher, here's your refresher. If it's something that you have wanted to do and you just weren't sure if you were allowed to, yes, you're allowed to. And of course, if you want a more detailed explanation, a few more examples of thinking about the questions this way, then I would be happy to do that. I realize I've taken it a little bit quickly just because I'm recording this on my lunch break. So I want to make sure I'm done recording before the end of my lunch break. But yeah, and I also want to give you guys time to go back to the last lesson and finish the word problems from there. So hopefully this makes sense. As always, let me know if you have any questions about this method or about anything else that we've talked about in this video. So that's it for this video. That's not it for today's class though, hopefully, because per my understanding, you guys haven't finished the word problems from last class yet. So I wanted to make this video a little bit shorter to give you guys time to go back to those, because if you struggled with the practice problems, it might be really hard to extract the right information from the word problems. So I want to make sure you guys have quite a bit of time to work on that. But yeah, of course, if you have any questions, let me know, leave me a comment, send me an Instagram message, WhatsApp, whatever works, and I will be happy to help you out. So that's it for this video, and good luck with the word problems. And if there are no further questions, then I will see you all in the next video. Have a good one.